Hello and welcome back to CPLEX OPL tutorial. In this tutorial I want to show you how to write or export the model in LP format so that you can check your constraints and your formulation. Especially when someone starts to learn modeling and optimization, the students usually have difficulties for understanding these LPs in compact form. So they have difficulties in writing the models in compact form using these sigma notations, using indices. In these situations, in order to check if your model is correct, if your formulas are correct, then after implementing your model in CPLEX, you can export it in open form, and then you can check your constraints, and it would be easier for you to check the formulas. And for this purpose, I'm going to use the models that I already developed in the previous tutorials. So in this first one, let me show you the model file. Basically, this is a simple model with only a single decision variable xi, and z represents the objective function, and we have these constraints. So if you are expert, if you worked on CPLEX and on your modeling, in fact, when you look at these constraints, you can easily understand what's going on. So you can simply say that, okay, in this line we have just a single constraint. This is just a single constraint. On the left hand side of the constraint we have the summation of ti times xi, and on the right hand side we have this available time, which is a single value. But when you look at to this constraint, you can say that, okay, here, since there's for all I in products, although it seems a single line, it is not a single constraint. So there are a number of constraints as this range products takes, and it takes this 1 up to the number of products, which is read from the data file, and it is read from the Excel file, and in fact in Excel this number of products is 5. So it means that in fact in this single line I'm writing 5 constraints. And as I said, if you are an expert, in fact you don't need to be an expert, but if you understood the idea, and it's easy to see this. But if you are a new learner, then as I said, it may be better to check the open form. And in order to do this, what we will do is just click on anywhere on your project, like including a mod file or a dot file, we will add a settings file. And how do we add it? Just right click on your model, on your project, and in the pop-up menu go to new and go to settings. Okay, select this settings and give a name to this settings file. You can say settings compact, just the name. Okay, and then let's say finish, and this setting files is established, and it is not like mod or dot file. It has a format. It includes several menus, and you will just select the settings from these menus. And first let me show you where is the settings files. As you can see, the settings compact file appears here with an extension of OPS. One of the most important things that you should never forget is, like the mod and dot files, these setting files should be inside your run configuration, otherwise it will not affect your run. So you should drag and drop this settings file into the run configuration that you want to run with. So look, now I have several run configurations under this project folder. Under this configuration, I have this settings file, but under this configuration I don't have. It means that if I run with this model, it will run with the settings that I changed in this file. But if I run this model, the default values of all these settings will be used. And currently in this settings file, since I didn't change anything, it will still run with the default settings. But as soon as I make some changes, then it will affect only this run configuration. And if you want to use the same run configuration for the other file as well, other configuration as well, then you need to drag and drop that under that also. And when you do, as you can see, the settings file appear here. And under a single project, as the model and dot files, you can have multiple setup files, settings files, and you can use different settings files with different configurations. And inside these settings files, as you can see, there are some main tabs on this left pane, and there are some main sections, and there are a lot of settings that you can play with. You can play with the CPLEX algorithm, which will affect the LP problems. You can work on these MIP, barrier, benders, network, and shifting. So these will affect the integer programming formulations or the formulations that have special types. So in CPLEX OPL, you can also solve constraint programming formulations, and the settings of those can be arranged here. And this language has some general settings about the CPLEX OPL. So today I will not go into details of the other settings, but I will only show you how you can export your file. And for this reason, you should go to this language, and under this language you should go to run. And when you click on this run, as you can see, there is this export format, and in this you can select different export formats. So if you just select LP format here and save this settings file, okay, so now we are ready to export our model. And where it will be exported, so and how? When you run your model, so in order to export your model, you should run it. So it should be free of errors, any kind of error, so that you should be able to run the model. Okay, how do we run? Just right click on the run configuration and click run this. And when the model runs, the LP is exported, the model is exported in open form. Okay, there is a problem, as you can see, with this Excel. So let me open the Excel file and let's see what is the error. So this is a good practice to see. So it's tutorial data 5 Pro, which is this one, and as you can see, it says P from Excel sheet profit, and let's see, P is up to end product. Okay, so here end product is 5 and profit, let's see. Okay, as you can see, let me go to the name manager over here, and as you can see, this profit goes from B2 to B11, but it should go from B2 to B6. Okay, so save it. Let's see what we have. So in all of these, I need to rearrange the names. Okay, let me do it in this way. This is the time. Yes. And the material, it should go from D2 to D6. And the demand should go from E2 to E6. So I guess we are done. I am going to save it. And let's run the model again and see if we are free of errors. When you do a lot of tests with your model with different data, you will have such errors time to time. Don't be afraid of these errors. You will always get such errors. The important thing, the most important thing, is to understand what is the mistake, what is the error, and how to correct it. And now the model is run, so we need to be able to find this LP file, exported file, and where is it? Basically, you should go to the project folder, and to do that, just right click on the project name, go to properties, the file location, the project folder is here. If you just click on this button, it will take you to the folder, and this is the folder. Click on it, and inside that you will see all the files of this project. And as you can see, this is my configuration name. As you can see, this is configuration read excel1, configuration read excel1, and the extension is LP. So you can open this with any text editor. Okay, just open it, and you will see your model in open form. Look how to read this. This is your objective, maximize. Objective is Z, and it says subject to. Let me do it in this way and show you the model file at the same time. Okay, so as you can see, my objective is to maximize Z, which is this one, and the first constraint is Z equals to this. As you can see on this right hand side, it is PIXI plus DI, summation of these over all I in products. So let's see, it is, as you can see, Z minus 8x1. So what is this 8? That 8 is P1. P1 times x1. 7.5 times x2, 5 times x3, 2 times x4, 2 times x5 equal to, well, okay, what is this value? And the format, as you can see, it's different. Here we have written Z equals to this, but here it is Z minus. So what is the reason? The reason is CPLEX collects every decision variable to the left hand side and every constant to the right hand side. So writes the compact form in this format. And what happened? So this PIXI is moved on the left hand side of this equation with Z minus this PIXI, and this DI is constant, so it's left on the right hand side, and this value is, in fact, it is the summation of this DIs over all I's. Okay, this is the first constraint, in fact, which defines the objective function. The second constraint, as you can see, this is sum TIXI less than or equal to available time. So look, this is 5 times x1. 5 is T1. T1 times x1 plus T2 times x2, T3 times x3, and etc. less than or equal to the right hand side, which is available time. So you can check if everything is correct, if the compact form is written correctly, and if the data is read correctly, data is written in these formulas correctly. Next one, mi(xi), so this is 21x1, 49x2, and you can check the mi values, the material. Look, 21x1, 49x2, 22x3, less than or equal to the right hand side, which is the available material. So this is the third constraint. Now look, fourth constraint. Instead of this first constraint, as you can see, I have 5 constraints, because this constraint is written for all I in products, and there are 5 products. And now what do we have? x1 less than or equal to this, x2 less than or equal to this, which is xi less than or equal to the demand at each I. The last constraint is this one, and as you can see, this constraint has a condition. It says that write this constraint for all I where the value of I is greater than or equal to 2. Okay, so that's why we don't have 5 constraints here, but instead we have 4 constraints, because the first one starts with inputting 2 instead of I, and again on this right hand side it's also a decision variable, so we need to move it to the left hand side. As you can see, this is minus x1, which is the right hand side, moved to the left hand side, and this is xi greater than or equal to xi minus 1, simply this is. Okay, so these 4 variables, and as you can see, if the decision variables have some bounds, then it is written here. Since my x variables are float positive, which means that they are greater than or equal to 0, it's not included here, but the z value, as you can see, it's free, so only the free one is denoted here, and this is the open form. Quickly, I will show another example. So this time let's consider this example first. Let me clean up the initial LP model. Okay, so now I'm going to, in order to export this model, the first thing is to establish a settings file. So I already, in fact, for this problem established, but let me delete it and do it again. Okay, what do we do? Right click anywhere on your project, go to new and go to settings, and give a name to this settings file. It is any name, so tutorial settings. Okay, and then it is opened, it is established, and it's open. As I told you, the most common mistake among the students is, okay, this file is already opened, they go to this run and they select this LP, and then they save it, okay, and then they go to the run configuration and run, and they cannot see the LP file, they cannot see the effect of this settings file. And what is the reason? Simply the reason is, in order this settings file to affect the run configuration, you have to move it under the run configuration. Okay, so I will just drag and drop it until the run configuration. So the model is already run, and as you can see, there is no LP file here. Now this LP file includes this settings, this configuration includes this settings file. So I am running this again. So let's wait for the run to complete. From this bottom right hand side, you can follow the time starting from the launch of the model until it solves. But if you want to see the branch and bound time, exact solution time, then you should go to this engine log, and inside this engine log you should look at the time that is given there. So as you can see, it says pre-solve time, it is 0.00 seconds. So all this time, 10 seconds, is spent on launching the model and etc. But once the run has started, then it took all negligible time, okay, to solve the model. It only 0.01 ticks. It found the optimal solution because this is an easy model. But there are some problems, some models that take hours and hours to solve it. Then you can follow that solution from this engine log tab. Okay, the solution is found. Then I need to go to the project folder to see this LP file, and again right click on your project, go to properties, and your project folder is this one, which is already open here. And as you can see, identical with my configuration name. Okay, as you can see, it's configuration XL1, configuration XL1. So when you have this settings file here, each time you run the model, it will export this LP. And the thing is, if your model is large, very large, then exporting this LP, writing the LP file will take a lot of time. Therefore, I suggest you to do this, to check your model only for one time and etc. And when you are sure that your model runs correctly, then take it back to the default value by clicking on this reset button and save your model and solve your model without this export option. Okay, do it only to check your model, or if you're going to use this file, this LP file in anywhere. Okay, so this is our LP file. So let's open that file. Now it is this file, and let's see the model file on the left hand side and the exported file on the right hand side. So my objective is to minimize Z. As you can see, minimize obj1, it says Z. Subject to the first constraint, it says Z equals to Cij times Xij. Again, all these variables are moved to the left hand side, so it's Z minus 5 times X11. So what is this 5? It is C11 times X11. C12, value of C12 times X12, C13 times X13, up to all C44 times X44, and it is equal to 0. Okay, now look at this constraint over here. This constraint is written for all machines, and in this example there are 4 machines. So it means that starting from this C2 to C5, these 4 constraints are the output of this single line. And it says summation over I. Look, I is the first index here. So what will happen? At each row, at each constraint, the first index will be increased. So let's look. X11, X21. As you can see, the first index is increased. X31, X41, equal to the right hand side. And then when we move to the next line, so this C increases from 1 to 2, so the second index becomes 2. As you can see, the second index is now 2. And what do we write? X12, X22, X32 is equal to 1. Up to this C5, we write it in this way. And the last constraint over here, it is, as you can see, written for all I in jobs. And again, since there are 4 jobs, starting from this constraint 6 to constraint 9, the 4 constraints are the output of this single line. And at each line, we fix the I to a single value starting from 1. So I is the first index. So look, the first index is 1, 2, 3, and 4. At each line, the first index changes. And inside the line, the summation is over j. J is the second index, and as you can see, x11 plus 12 plus 13 plus 14 is equal to 1. Okay, in the second one, 21, 22, 23, and 24 is equal to 1. And as you can see here, we write these constraints as to write an equality constraint in CPLEX, you simply write equal equal, but here, as you can see, it's just single equal. And also, as you can see here, the right hand side we have a semicolon. We end each line with a semicolon, but in the exported one, as you can see, there are no semicolon. So this is the format of the LP file. Basically, because of this, you don't have those. And some software, some other programs may accept this LP format. So you can export your model from CPLEX OPL in LP format. Then you can input this LP format to, for example, another solver, another user interface, GAMS. You can just import it and solve the same model in that solver. It is possible. So this is how we can export a model in CPLEX OPL and check if everything is correct or not. So we will continue to make to do different examples. We will continue